Download this code from codegive.com, link in the description below. Logging Subsystem Overview, a comprehensive tutorial with code examples. Logging is a crucial aspect of any software application, providing valuable insights into its behavior, performance, and potential errors. A well-designed logging system enables developers and administrators to debug issues, trace the execution flow, examine variable values, and pinpoint the source of errors. Monitor application health, track key metrics like response times, resource usage, and critical events. Analyze performance, identify bottlenecks and areas for optimization. Audit security events, record login attempts, data access, and other security-sensitive actions. Troubleshoot in production, diagnose problems in real-world environments without attaching debuggers. This tutorial provides a comprehensive overview of logging subsystems, covering key concepts, best practices, and practical code examples across different programming languages. Core concepts of logging. 1. Log levels. Log levels classify the severity or importance of a log message. Common log levels, from least to most severe, are debug detailed information useful for debugging. Typically enabled in development environments but often disabled in production. Info informational messages about the normal operation of the application. Useful for monitoring high-level activities. Warning indicates a potential problem or unexpected behavior that doesn't necessarily cause an error but should be investigated. Error indicates a recoverable error or an issue that prevents a specific operation from completing successfully. Critical/fatal indicates a severe error that may lead to application termination or data loss. Requires immediate attention. 2. Loggers. Loggers are the components within your application that generate log messages. They are typically organized hierarchically, reflecting the structure of your code. For instance, you might have loggers named myapp, myapp.module1, and myapp.module1.submodule. 3. Handlers. Handlers determine where log messages are sent. Common handler types include console handler writes log messages to the console, standard output or standard error. File handler writes log messages to a file. You can configure file rotation to prevent log files from growing indefinitely. Network handler, example syslog handler sends log messages over the network to a centralized logging server. Database handler writes log messages to a database. 4. Formatters. Formatters control the appearance of log messages. They define the layout of each log entry, specifying elements such as the timestamp, log level, logger name, and the actual message. 5. Filters. Filters selectively allow or deny log messages based on specific criteria, such as log level, logger name, or message content. 2. Logging subsystem architecture. A typical logging subsystem follows a hierarchical architecture. 1. Your application code calls the logging API, example logger.info, message. 2. The logger receives the log message. 3. The logger may apply filters. If the message passes, it's passed to the handlers. 4. Each handler applies its own filters. If the message passes, it's formatted using the handler's configured formatter. 5. The formatted log message is then written to the handler's destination, example console, file. 3. Code examples, Python. Python's logging module is a powerful and flexible logging library. Explanation of the Python code *. Logging.basic config, Asterisk provides a basic configuration that's suitable for simple scripts. It creates a stream handler, writes to the console, with a default formatter. Asterisk logging.getLogger, _ name _ asterisk retrieves a logger instance. _ name _ automatically gets set to the name of the current module. Using module-specific loggers makes debugging and filtering easier. Asterisk logger.setLevel, asterisk sets the threshold for log messages. Only messages with a level equal to or higher than this level will be processed. Asterisk logging.handlers.rotating file handler, asterisk creates a file handler that automatically rotates log files when they reach a certain size, preventing them from growing too large. Max bytes specifies the maximum size of each file, and backup count determines the number of old log files to keep. Asterisk logging.formatter, asterisk defines the format string for log messages. Percent, time, S represents the timestamp, percent, name, S the logger name, percent, level name, S the log level, and percent, message, S the actual message. Asterisk logger.addHandler, asterisk adds a handler to the logger. A logger can have multiple handlers, sending messages to different destinations. Asterisk logger.exception, asterisk logs an exception and its traceback information, which is extremely helpful for debugging errors. Asterisk logging.config.fileconfig, asterisk reads logging configuration from a configuration file, example logging.conf. This is the recommended approach for larger projects because it allows you to manage logging settings separately from your code. Asterisk logging.config.dictconfig, asterisk allows loading logging configuration from a dictionary, often created by parsing a YAML or JSON file. This offers flexibility for dynamic configuration. 4. Code examples, Java using SLF4J and logback. Java doesn't have a built-in logging system like Python's logging module. The standard approach is to use a logging facade, SLF4J, in conjunction with a logging implementation, logback, log4j2, etc. SLF4J, simple logging facade for Java, provides an abstraction layer that allows you to switch between different logging implementations without changing your code. Logback is a popular and performant logging implementation. 1. Dependencies, Maven add these dependencies to your pom.xml. 2. Java code asterisk. 3. Logback configuration, logback.xml create a logback.xml file in your src/main/resources directory, or a location on the class path. This file configures logback's behavior. Explanation of the Java/logback code asterisk. Asterisk logger factory.getLogger, myapp.class, asterisk gets a logger instance for the myapp class. Using the class name as the logger name is a common practice. Asterisk logger.debug, logger.info, logger.warn, logger.error, asterisk methods for logging messages at different levels. The second logger.error, call logs the exception E along with the message, providing a stack trace. Asterisk logback.xml asterisk the configuration file defines appenders, stout and file, encoders, which format the log messages, rolling policies, for file rotation, and the root logger, which applies to all loggers by default. Asterisk appender name equals stout asterisk configures a console appender that writes to standard output. Asterisk appender name equals file asterisk configures a rolling file appender that writes to myapp.log and rotates the files daily. Asterisk rolling policy asterisk defines how the log files are rotated. Time-based rolling policy rotates the files based on time, in this case, daily. Asterisk root level equals info asterisk sets the default log level for the root logger to info. This means that debug messages will not be logged unless explicitly configured for a specific logger. Logger name equals myapp level equals debug dvd equals false configures the logger specifically for the myapp class. It sets the level to debug, meaning debug messages will be logged, and disables dvd. dvd equals false prevents messages logged by this logger from also being logged by the root logger. Key considerations and best practices. Choose the right log level. Use debug for detailed information that's only needed during development, info for normal operation, warning for potential problems, error for recoverable errors, and critical for severe errors. Use meaningful log messages. Write log messages that are clear, concise, and informative. Include relevant context, such as variable values, function names, and user identifiers. Avoid overly verbose or cryptic messages. Avoid logging sensitive information. Never log passwords, credit card numbers, personal health information, FI, or other sensitive data. If you need to log such data, consider anonymizing or masking it. Use structured logging, where possible. Structured logging involves logging data in a structured format, example JSON, rather than plain text. This makes it easier to search, analyze, and correlate log events using tools like Elasticsearch or Splunk. Libraries like structlog, Python, simplify structured logging. Centralized logging. Consider using a centralized logging server to collect and analyze logs from multiple applications. This provides a single point of access for log data and simplifies troubleshooting. Popular centralized logging solutions include the Elk Stack, Elasticsearch, Logstash, Kibana, Splunk, and Graylog. Log aggregation and analysis tools. Utilize log aggregation and analysis tools to extract insights from your logs. These tools allow you to search for specific events, create dashboards, generate alerts, and identify trends. Log rotation and archiving. Implement log rotation to prevent log files from consuming too much disk space. Archive old log files for auditing and historical analysis. Avoid logging in production for performance reasons. Extensive debug or trace level logging can significantly degrade performance. Configure your logging levels appropriately for each environment, development, testing, production. Asynchronous logging. For high volume logging scenarios, consider using asynchronous logging to avoid blocking the main application thread. This can improve performance by offloading logging operations to a separate thread or process. Correlation IDs. Implement correlation IDs to track requests across multiple services. Include the correlation ID in log messages to easily trace the flow of a request through your system. Error handling. Ensure that your logging code handles exceptions gracefully. Don't let logging errors crash your application. Testing. Test your logging configuration to ensure that messages are being logged at the correct levels and to the correct destinations. Verify that log rotation is working correctly. Security. Protect your log files from unauthorized access. Restrict access to log files to authorized personnel only. Encrypt log files if they contain sensitive information. 6. Common logging libraries and frameworks. Python logging, built-in. Structlog, for structured logging. Loguru, a more user-friendly logging library. Java SLF4J, logging facade. Logback, logging implementation. *log4j2, logging implementation. *JavaScript, Node.js. *Winston. *Pino. *Bunyan. *C, .NET. *Microsoft.extensions.logging, built-in. *nlog. *Serolog. 7. Conclusion. A well-designed logging system is an essential part of any software application. By following the principles and best practices outlined in this tutorial, you can create a logging system that provides valuable insights into your application's behavior, helps you debug issues efficiently, and improves the overall reliability and maintainability of your software. Remember to choose a logging framework that suits your language and project's needs, and carefully configure your logging levels and destinations to balance performance and information gathering. Consider structured logging and centralized log management for larger, more complex systems.